Good morning all, this is Jalakshmi of EC Department of NPR College of Engineering and Technology. Today we are going to discuss about that avionics system. It's a elective subject for the electronics and communication engineering. So let me start with that what we are going to discuss in this avionics system. Let me start with that unit 1, Introduction to Avionics. Here we are going to discuss about the basics of that avionics system, what are all there in the cockpits, what is the need for the avionics systems, and what is there in the military and civil aircraft and space systems. Then we are going to discuss about that integrated avionics system, that architecture of the avionics systems, especially for military and civil aircraft, how they are manufactured, how they are designed, what are the requirements for that avionics system, and the importance of the avionics system. And then we are going to finally discuss about the utilities of avionics system. Let me start with that one. What is avionics? Avionics, it's a combination of aviation and electronics. What is that? Aviation means it's a study about that aircraft. Okay, the basic concepts of the aircraft that we will discuss that in the aviation. Then we are combining that with the electronics, that is called as avionics, where we are using the electronics in the aircraft to control the aircraft. We are using the electronic systems, so that is called as avionics. There is a study of aviation as well as electronics. Okay, then what is the necessity why we are going for this avionics system means it is a very big industry, major multi-billion dollar industry worldwide, because most of the amount we are spending to design an aircraft, to manufacture an aircraft, is occupied by these aviation systems. So for example, if you are taking that one, if it is a marine patrol or anti-submarine aircraft, it is around 40% of the manufacturing cost is occupied by your avionics. And if it is a military aircraft, that is AWACS system, around 75% of the total cost, manufacturing cost, is occupied by your avionics only. Next, what are all the essentials of this avionics system? Why should we go for this avionics system? To enable the flight crew to carry out the aircraft mission safely and efficiently. If it is a civil type of, what may be the mission? Mission means you have to take, when you are taking that aircraft. If it is a civil aircraft means we have to carry the passengers very carefully, and we have to safely land them in a destination. If it is a military aircraft means intercepting a hostile aircraft, attacking a ground target, and then we have to safely reach our target also at any weather condition. That is essentials for this avionics systems. Then what are all the major drivers in the development of an avionics system? It's to meet the mission requirements with the minimum flight crew, we have to go for this avionics system. What is that minimum flight crew? Suppose if you are having a civil aircraft, if you want to fly within a civil aircraft, we know that one there will be a pilot and there will be a co-pilot. If you are having an avionics system, if that single pilot is enough to control the entire aircraft, that is an economic benefits. That is, we are saving the salary of a crew, as well as we are reducing the training cost for another one crew. Okay, so we are reducing the we are reducing the cost by this one we are getting the economic benefits. Then we are reducing the weight of the flight. So how we are reducing the weight of the flight means, since we are using the electronic components to control instead of mechanical component, we are using electronic components to control the aircraft. So the weight of the electronic components is very less compared to your mechanical components. So using that weight, we can take more number of passengers, and we can reduce the fuel consumption. Okay, that is the major driver components in this one. Then if it is a military type of aircraft means, a single seat fighter or strike aircraft is lighter. Since the weight of the aircraft is light, we can go for the more weapons can be occupied with this one. So its cost is less compared to a two-seat aircraft. Then and it eliminates the second crew. Already we have discussed that one. So the second crew training as well as salary can be reduced. Next, other important drivers of our avionics systems are increased safety compared to our mechanical drivers. Here we are having a electronic system which gives accurate readings of our circumstance. So we can safely land, and air traffic control requirements are comparatively less. At any weather condition, you can operate our flight, and it reduces the fuel consumptions. It improves the aircraft performance and controls and handling, and it reduces the maintenance costs. So totally the avionics system, in the case of military, we can achieve our target. In the case of civil aircraft, we can get the benefits like reducing the cost, economic benefits are more. Next, we are going to discuss about that core aircraft subsystem. So here is the architecture of your avionics system. So if you see that one, there is a pilot in front of them, there is a display unit, then he is having the communication units, and near to his hands he is having the data entry and control unit. Then we are having the flight control systems. Then majorly they are having that aircraft state sensors that they are giving about that air data systems, and then inertial sensors. Then we are having the navigation, radio navigation system. In that one especially we are having DR navigation system. Then we are having external world sensors that will give the data about that radar data will be given by that. Then we are having the control systems, that is housekeeping system, navigation system, autopilot system, and then we are having engine control system. Okay, let me start with that one by one. The core avionics system, it's a hierarchical structure. It comprises of layers of specific tasks and avionics system functions for enabling the crew to carry out the aircraft mission. When you are talking about that one, we see that one layer by layer we are having that. When you are discussing about that architecture, we have seen that one there are so many layers. First one is our display layer, then we are having communication layers. So we are having so many layers. So let me start them one by one. What is that function of the display system? It provides the virtual interface between the pilot and the aircraft system. Virtual interface means we have to get the data about where we are and where we have to land. These data has to be displayed in the system. So for that one we are in the need of the display systems. There are three types of display systems are there. One is head-up display, then another one is head-mounted display, then we are having head-level display also. Next, we are having the communication system. It provides the two-way communication between the ground bases and aircraft, or between two aircrafts. So to communicate between the two aircrafts, we are having two-way communication systems. There will be a radio transmitter and receiver in each avionics systems. So by transmitting the messages or by transmitting the radio audio signals, we can communicate with the destination. The different types of frequencies used for several ranges are given here. For long range communication, we know that, and as a ECE student, you know that one high frequency range is between 2 to 30 megahertz, and then medium range communication we are having a very high frequency from between 30 to 100 megahertz. When you are taking that military aircraft, we are having ultra high frequency range from 250 to 400 megahertz. Nowadays, satellite communication systems are used to provide very accurate long distance communication. Then the next unit is data entry and control system. It is essential for the crew to interact with the aviation system. So to give a commands or to receive the data, we are in need of the data entry and the control systems. Then flight control system. It uses the electronic systems in two areas. First one is auto stabilization, then is fly-by-wire or flight control system. Auto stabilization means once you start from land, how you have to be stabilize the aircraft, then we have to control the aircraft towards the destination. So that is controlled by this flight control system. Then we are having that aircraft state sensor system. This is a sensor system. So already you know that one, what are all the use of the sensor system. Here we are having the aircraft state sensor systems. It is used for control and navigation of aircraft. Air data quantities are essential. So to control the aircraft, we are in need of the data quantities like attitude, altitude, and airspeed, true airspeed, Mach number, vertical speed, calibrated airspeed, airstream incidence angle. These are all some data we are in need to calculate the destination and where we are now. That this can be calculated with these data. These data can be achieved collected from the aircraft state sensor system. Next, radio navigation systems. Here For fixing the aircraft, for position fixing systems, we are in need of the radio navigation systems. Satellites are ground based transmitters used to transmit the signal, and it was received by the receiver in the aircraft. After receiving the data, we can analyze that where we are and where we have to reach. According to the received signals, a supporting computer is used to derive the aircraft position. Then the primary position fixing system used in aircraft is GPS. Here we are using GPS to fix the primary position of the aircraft. Then instrument landing systems. ILS is instrument landing system. When you are landing your aircraft, instrument landing systems or microwave landing system is used for approach guidance of the airfield. Next, outside world sensor system. This system comprises both radar and infrared sensors, which enables all weather and nighttime operation. So, using the radar, we can obtain the data about objects before us, and using that one at all weather condition at a night time also you can receive the data. Next, inertial reference system. The aircraft altitude and the direction in which it is heading are provided by the inertial sensor systems. So, using that inertial sensor system, you can obtain the data like the direction, that is heading direction where we are moving towards, as well as the altitude of our aviation aircraft. Next, navigation system. The navigation system provides navigation information like the position, the ground speed, tracking angle. For that one, we are using depth reckoning system or position fixing system. These two are the systems to calculate the altitude and position of your navigation system. Then types of DR navigation system. Mostly we are going with the DR navigation system, especially in that one inertial navigation system. Most accurate system is that one. Or else based on the requirements we can use Doppler or heading reference system, that is mostly used in the helicopters, or else we can go for the air data or heading reference system. Compared to our INS system, this is having very less accuracy. Next, we are going for that just a minute. Radar system, whether radar detects even we are using radar system to detect the water droplets, cloud turbulence, and warning. We can get the warning about that storms. Using this radar system, you can get all these data. Then when you are going for the fighter aircraft radars, they are used for multi-mode radars are used here for ground attack, and to know about that interception of other aircrafts within 100 miles, how many radar aircrafts are there surrounding us, that we can find with this fight aircraft radars. Then the radar must have a look down capability to track low flying aircrafts below us also. Okay, this is all the radar system we are providing. Then we are having the infrared system. It is used to provide a video picture of the thermal image scene of the outside world by using fixed forward looking infrared sensors or a gimbal IR managing sensors. Using these sensors, you can identify the based on the temperature condition what all the objects available there. Okay, so the thermal images at night look similar to the visual picture in daytime also. Okay, so using that one we can get the more data, that is more deepest data, accurate data using this one. Next, we are going for the task automation system. The task automation systems are reduce the workload of the flight crew. Automatically, if you are going with that autopilot system, then if we are flying for long distance, once you fix the destination, then the flight will be under that autopilot mode. So, the flight workload will be reduced in this one. Then navigation management system, it comprises the operation of all radio navigation and a combination of data from all navigation sources such as GPS, INS system, and then it provides the best estimation of the aircraft position and the ground speed. So, by calculating the best position and best destination route, then we can go with that accurate decision. Okay. Then autopilots and flight management system. The autopilot relieves the pilot in long range mission. Then the flight management systems come into use from the 1980s itself. They are giving the flight planning, navigation management, engine control to maintain the planned speed, then control aircraft flight path, then it reduces minimize the fuel consumption, it ensures the aircraft at a planned position, okay, in a 3D position it gives. Okay, these are all the uses of your air data control system, flight management systems. So far we have discussed about all the architecture, core avionics architecture. So let me start with that next topic in the next unit. Thank you.